Hello. Today we're going to talk about quadratic equations and problem solving. So let's start with a definition. A quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c equals 0. We make sure a, b, and c, they're just constants, they're numbers. But a cannot be 0. Again, if a is 0, then we'll just have a linear function instead of quadratic. So there are many ways we could solve quadratic equations, like probably too many for me to list here off the top of my head. But there are three that we focus on: factoring, the square root property, and the quadratic formula. These are kind of the big three of solving quadratic equations. So let's talk about factoring first. In factoring, to solve an equation is based on the zero factor property. This property is the most appropriately named of all of our properties because it tells you exactly what to do. First, you set the equation equal to 0. Then you factor completely. And then you use the property. What does the property say? The property says if you have two numbers, a and b, that multiply to be 0, then either a is 0 or b is 0. That's it. So if we could set things up, and this translates to more than two factors as well. You could have 4, 5, 6 things multiplied together to be 0. You set each one equal to 0 in order to solve. So let's use the zero factor property, or solve by factoring, with a couple of examples. Let's go with blue. So the first step, get it equal to 0. So let's subtract 1 from both sides. We'll have x squared plus x minus 12 equals 0. Second step, we're going to factor. All right, so we got it equal to 0. Now we're going to factor. To factor x squared, we will have x times x. We want two numbers that multiply to be a negative 12, and they add to be 1. So multiply to be negative 12, we know they have to have opposite signs, so we'll have 1 and 12, we'll have 2 and 6, we'll have 3 and 4. One's negative, one's positive. Since the output is positive when you add them, the smaller numbers would have to be the negative ones. And to get a positive 1, we'll use negative 3 and positive 4. So we factored, and now our property, we haven't factored yet. I can't forget this important little equals 0. We always want to keep it as an equation. We don't want just factors floating around. Keep it as an equation so you remember that you're trying to solve. Right, there's actually solutions to this. So the equals 0 is super important. I'm sorry I forgot that for a minute. The property now says x minus 3 is 0, or x plus 4 is 0, in which case x equals 3, or x equals negative 4. We could check our answers. 3 squared is 9. 9 plus 3 is 12. 12 minus 11 is 1. And you can check negative 4 on your own. Again, we're going to do 0. So we subtract 2t from both sides. Then we're going to factor. We could take a t out of each term. And then we're going to use the property. T equals 0, or t minus 2 equals 0. T equals 0 is already solved. Add 2 to both sides, and we get t equals 2. Let's put a note of caution here. I'm learning Spanish. Oh, that's upside down. It's not upside down. It needs to be upside down. Caution, cuidado. When you have this, do not do this. Do not just divide both sides by t. What happens here is you assumed t is not 0 by dividing. You can never divide by 0, right? So by dividing by t, you don't know if t is 0 or not. So we don't want to divide in order to solve. We always want to factor. That way we don't lose one of our solutions. All right, and now the big one. So we'll get it equal to 0. We have 2x squared minus 13x. minus 15 equals 0. Then we'll want to factor. We're going to use the AC method to factor here. We're going to multiply 2 times a negative 15 to get negative 30. We want to multiply to be negative 30, and we want to add to be a negative 13. When I see the 30 and the 13, I'm thinking, I'm looking at tens here. So I'm going to multiply 3 times 10 to get negative 30. Oh, but if it's a negative 30, one of these would have to be negative. It doesn't work out. When I add negative 30, my result has to be negative. This is only going to give me a negative 7. Bummer. So I list the rest. I want my result to be negative when I add, so my bigger numbers will be negative. 2 and, oh, look at that. So even though instinct says 3 and 10, 3 and 10, because of the sign, we have to be careful as we write that. So in order to factor, I'm going to rewrite 2x squared minus 13x minus 15 as 2x squared plus 2x minus 15x minus 15. Notice the 2x and the negative 15x make that negative 13x. Now I can take these first two, factor out a 2x. I'm left with an x plus 1. Always use the sign in the middle. 15x minus 15 has a 15 in common. Minus 15x divided by a negative 15 is x. Negative 15 divided by a negative 15 is a positive 1. They have an x plus 1 in common. I'm forgetting the equals 0 again. They have an x plus 1 in common. What remains is 2x minus 15, and this equals 0. And so we finished our factoring. Now we can pop over here and use the property to get x plus 1 equals 0, or 2x minus 15 equals 0. For x plus 1 equals 0, x equals negative 1. And if we add 15 and divide by 2, we'll find that x could also be 15 halves. Solving using the zero factor property. All right. The square root property. The square root property, we're going to assume that k is a non-negative number. Non-negative means it could be 0 or positive. Then the solutions to the form x squared equals k are given by x equals plus or minus the square root of k. Another way of saying this is if I have anything inside a square equal to k, the property will allow us to take it out of the square by taking the square root of both sides. And when we take the square root of both sides, remember, we don't know if it was positive or negative when we squared it to get the positive and the non-negative result. So we have to accept the possibility of either positive or negative. Let's see an example here of baseball. Baseball is dropped from a stadium seat that's 75 feet above the ground. Its height s, so the height of the baseball, in feet after t seconds is given by s of t equals 75 minus 16t squared. Estimate to the nearest tenth, so I'm going to use a calculator, of a second, how long it takes for the baseball to strike the ground. The ground has a height of 0. Estimate to the nearest tenth of a second, how long? How long tells us to find a time. So find the time when s is 0. So I will solve 0 equals 75 minus 16t squared. In order to use our square root property, let's add 16t squared to both sides. Then we'll divide by 16. Now using the square root property, we find that t equals plus or minus the square root of 75 over 16. And generally, I'm a big fan of simplifying this on your own. And if we just do a quick and dirty here, I know the square root of 16 is 4. The square root of 75, no. But 75 is 3 times 25. But if you tell somebody it's going to take 3 square root of 5 over 4 seconds for something to happen, if they don't slap you, they'll probably shake their head and run away. So keep in mind, we want the nearest tenth of a second. This is a real life problem. We want a real people answer, not real purple, but real people answer. So not just a nonsense type of time. Also keep in mind that in the real life situation, the negative is not going to apply. 3 squared of 5 over 4. I'm going to put in my calculator the easier version, which is the square root of 75 divided by 16. It's all under the radical. That's awesome. 2.2 seconds for this baseball to drop 75 feet from the stadium seat to the ground level. All right, 2.2 seconds. A lot of times this is our math answer, but math is only as useful as our ability to translate it, so make sure you put it in terms of something that's understandable for the question that's proposed. Square root property also useful when you're completing the square. So if I complete the square here to solve, I could take half of 5 and square it. And when I square 5 halves, that means I'm going to add 25/4 to both sides. 5 squared is 25. 2 squared is 4. That's a 4, not a 9, I promise. And we happen to know exactly how this factors. This 5 halves, that number that we squared, that's what goes in the parentheses. 4 plus 25/4. Since I have my calculator out and ready, I'm going to go ahead and use, no, I'm not. I'm going to use the fraction. 41/4. The square root property now says that x plus 5 halves equals plus or minus the square root of 41/4. The square root of 4 is 2. So I'm going to put a little note here. The division property of radicals. And to finish this off, we would subtract 5 halves from both sides. And we'd leave our answer. This one does not ask us to give a decimal approximation, so we would leave it. On some online homework systems, you might have to write 2 separate answers, -5 halves plus the square root of 41/2, comma, -5 halves minus the square root of 41/2. It just depends on which online system you're using, if you're using an online system. At this point, most faculty are. The third method is a quadratic formula. Now, factoring works on the nice ones, the nice ones that can factor easily and nicely. And some people don't think anything factors nicely, and that's all right. Solving by completing the square only works out if you have things set up well. Quadratic formula works every single time. As we're working the quadratic formula, I'm going to write A is 1, B is 3, but before I write C, keep in mind the quadratic formula will only solve if the equation is first written in standard form, ax squared plus bx plus c equals 0. So anytime we see a quadratic, we're going to get it equal to 0 and decide how to work. So this is x squared plus 3x minus 8 equals 0. So my c value is -8. You must take the a, b, and c from the equation when it's set equal to 0. Now, the solutions will be of the form negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Very important. We're going to simplify the square root, then the fraction. Always simplify the square root first, and then we simplify the fraction. So we'll have negative 3 plus or minus. 3 squared is 9. A negative 4 times 1 is negative 4. Negative 4 times negative 8 is a positive 32. 32 and 9 makes 41. Interesting. It's almost the exact same solution we had here. And we're going to leave it that negative 3 plus or minus the square root of 41 over 2. And you can see in our last two examples, two different ways to write solutions, whether they're separate fractions or if you write them together, it's going to be all right. We could, if this fraction simplified, I would then look at it piecewise and simplify each independent fraction on its own. All right. Now this 41 that's inside the square root, that has a special name. Inside the radical of the quadratic formula, we have what is called the discriminant. So the discriminant is b squared. That's not a b, that's a d. We all do it. B squared minus 4ac is the discriminant. And if you're looking at a quadratic equation that's equal to 0, so it's in standard form, as long as a is not 0, the discriminant tells us three different things. If the discriminant is positive, like it was with the 41, there are two real solutions. And so it will look like this on a graph. You will actually have 2 times we cross the x-intercept. If b squared minus 4ac equals 0, there's only one real solution. And whether the graph opens up or opens down, what it will be is the vertex is your only x-intercept. And finally, if b squared minus 4ac, if the discriminant is less than 0, there are no real solutions. So maybe the graph looks like this, and it never crosses the x-axis. So there's three different things that can happen. Either we could have 2 x-intercepts, 1 x-intercept, or none. And the discriminant, it discriminates between the types of solutions. That should be the only discrimination that we see. So we're going to rewrite the equation in standard form and then use the discriminant to determine the number of real solutions. Then we'll solve just to make sure we're right. So let's start here. Write it in standard form. The discriminant, I'm going to write a equals 3, b equals 0 because there is no x term, c equals a negative 12. My discriminant, b squared minus 4ac, tells us 0 squared minus 4 times 3 times a negative 12. That's 0. I have a negative, a positive, and a negative, so that'll be plus. 4 times 3 is 12. 12 times 12 is 144. And it looks like there will be 2 real solutions. So we can predict what we're going to get. And it's nice that this is already worked out because also we can find, using the quadratic formula, negative 0, right, because it's the b value. Just go with it for right now. Square root of 144, because I've already found the value of my discriminant, over 2 times a. 2 times 3 is 6. Okay, so this is 0. Plus or minus, the square root of 144 is 12 all over 6, which is plus or minus 2. So if we were to graph this, we would find that our x-intercepts are at plus and minus 2. To solve 8x squared minus 2x equals negative 14, first step, set equal to 0. That's a 0. That's an ugly 0, but it is still a 0. Our discriminant is negative 2 squared minus 4 times 8 times 14. This is a 4 minus 4 times 8 times 14. 448. And if I do 4 minus 448, I'll end up with negative 44, 3/4, 444. So this is no real solutions. And it turns out that we'll have two complex solutions to this. So to solve, we'll have x equals a negative b plus or minus the square root of negative 444 all over 2a. And since we're looking for real solutions, we would say just no real solutions. But we might also consider, I'm just going to see if I know the square root. We don't. 444, let's put this as an aside. Let's see if we could see this yellow. 444 is 4 times 111. So this is 2. Square root of 4 is 2. I from the square root of the negative. Square root of 111 all over 16. If we were to simplify one more step, I'm going to see about moving that down a little bit. There we go. If we simplify one more step, we would write 2 over 16 plus or minus 2i square root of 111 over 16. Simplify the individual fractions. 1/8 plus or minus I square root of 111 all over 8. All right. One more. First one had 2 real solutions. The second one had no real solutions. Those of you that have taken any classes from me before can probably guess what this is going to have. But we're going to do it anyway. B squared, so that's negative 2 squared, minus 4 times a times c. Negative 2 squared is 4. Notice how I use parentheses every time. Maybe I didn't with the 0. I didn't use parentheses on the 0. But I use parentheses to make sure that negative gets squared as well. So there should be one real solution. Let's take a look. Our x values are negative b plus or minus the square root of 0 all over 2 times a. This is 2. Square root of 0 is 0. If I add 0, it's the same as if I subtract 0. There is only one solution, and so our x-intercept will be at the vertex, which is x-coordinate of the vertex, which is at x equals 1. Sorry, I just got lost there. I want to point something out really quick. As we're looking at the quadratic formula, did you notice that this part is our vertex formula? Right? It's built in. So we have the vertex plus or minus the discriminant. So are we adding to go left and right, or are we not adding to go left and right? If we're adding 0, well, of course, just the vertex is going to be exactly where we are for the x-intercept. So a little bit of connecting concepts. All right, 2 more examples, and then we'll be finished with this lecture. I know it's getting a little long. This example I wanted to do because it's one of the only projects I remember from industrial arts with Mr. Mayer. Nope, this was with, I called my teacher Kurt because Mr. Hoffman was weird because he's my cousin. Small towns, that's what happens. But yeah, we did this with Mr. Hoffman. Shout out to Kurt and Carrie. A box is being constructed by cutting 2-inch squares from the corners of a square sheet of metal. Before I go on, I'm going to draw a square sheet of metal, and then I'm going to draw the fact that I'm going to remove 2-inch corners from all 4 corners. Drawing an image is helpful. Does it have to be accurate? Does it have to be completely representative? No, it just has to be enough to let you know. Now, if we fold up on these dotted areas, we'll make an open top box. We actually made, I'm old enough that we made one for cassettes. I used mine as sheet metal. to store cassettes in one of our cars. That's old. Old. Okay. The box has a volume of cubic inches. All right, it's a volume. So volume of a box is length times width times height. All right, when I fold this up, this square area, I'm going to have to think about how I'm folding this. There we go. If these are the 2 inches, this will be, I don't know how much that will be. We need to find the dimensions. So let's make some dimensions. Let's call this whole distance x. Since this is a square, this distance will also be x, which makes our distance inside x minus 4. Think about it. Minus 2 here, minus 2 here. So we'll have x minus 4. All right, so x minus 4, and a width of 2. So our volume, we will have 2 times x minus 4 times x minus 4 equals 1058. So now we need to find the dimensions. We need to find x. Find the dimensions of the sheet metal. That will give us the total outside dimensions before we cut off our 4 corners. Let's multiply. 2 times x squared minus 4x plus 16 equals 1058. I'm going to do kind of some non-standard operations here. Most people would now tell you, okay, distribute the 2, and then we'll get the 1058 all together, and that's a fabulous idea. But I'm going to do this instead. I'm going to divide both sides by 2. Because I like to work with smaller values if possible. So now I have x squared minus 8x plus 16, because this 2 canceled that 2. Right? It only cancels in between pluses and minuses, but this 2 is being multiplied by everything in parentheses, so it only cancels once. Half of 1058 is a 529. Now to solve, I'm going to set it equal to 0. So I would like to do a 16 minus 529. All right, I'll be honest. I want to make sure that my 529's right. 16 minus 529 is a negative 513. And I'm going to use the quadratic formula. Anytime I have it simplified like this, I see a number like 513. 3 goes into it. Actually, 9 goes into it also. But I don't want to factor that. I don't want to complete the square to use the square root property. I'm going to jump straight to the quadratic formula. Negative b plus or minus our discriminant. That's negative 8 squared minus 4 times 1 times a negative 513 all over 2 times 1. So let's do the discriminant here on our calculator. Negative 8 squared. I use parentheses just like I did here. Negative 8 squared minus 4 times 1 times a negative 513, but I didn't use parentheses there because my consistency is lacking. Plus or minus the square root of 2116 all over 2. Let's see, do we have a nice square root here? Oh, isn't that a beautiful thing? This is 8 plus or minus 46 all over 2. So we have 8 plus 46 all over 2. Which is a 54 over 2. Yes, I probably knew that. And 54 over 2 is 27. 27 inches. Our other answer, 8 minus 46 all over 2. 8 minus 46 all over 2 is a negative 19. But in terms of the problem, this answer, we are not going to have a negative 19-inch square sheet of sheet metal. We're going to take 27 inches as our answer. And you can check it and make sure it all works out too. All right, a cylindrical, I forgot, there's still 2 more examples. A cylindrical aluminum can is being constructed to have a height of 4 inches. If the can is to have a volume of 28 cubic inches, approximate its radius r. And we're going to go 2 decimal places. And exact. All right, now a hint given here is the volume of a cylindrical can. This is called a right circular cylinder. Is volume equals pi r squared h. We know the volume is 28. We have no idea what the radius is, but we know the height is 4. So we could rewrite this. 28 equals 4 pi r squared. In order to solve, I'm not going to use the quadratic formula. I have r only in a single term. I'm going to complete this. I'm not going to complete the square. I'm going to use the square root property. When I divide by 4 pi on both sides, I'll get r squared on the right. 28 divided by 28 divided by 4 is 7. We still have the pi. R equals plus or minus the square root of 7 over pi. But we know radius is not negative. So our radius will be the square root of 7 over pi, which is approximately 1.49 inches. All right, so the radius of the can, approximately 1.49 inches, 3-inch diameter, 4-inch height, approximately 28 cubic inches of aluminum. All right. Last problem, and this is going to be primarily on our calculator. Some types of worms have a remarkable capacity to live without moisture. The table shows the number of worms Y surviving after X days in one particular study. All right, so we have the table. Use regression to find a quadratic model for this data. So the first thing we're going to do is we are going to go to stat and we're going to enter our data. In list 1, we're going to put the X values. And in list 2, we'll put the Y values that correspond to them. Now we're told that we want to find a quadratic model, so I'm going to quit out of here, go back to stat, and calculate a quadratic regression. So that's number 5. List 1 is my X value, list 2 is my Y value. I want to store this equation, so I'm going to go to variables, over to Y variables. I want functions, I want Y1. So this will allow the graph to show at the same time, and I can calculate my quadratic regression. Let's get the right thing here. Our regression is, it gives us the A, the B, and the C. Let's use, say, 3 decimal places. Hopefully that'll be enough. Negative 0.001 x squared minus 0.076. Our 5 will be rounded up. My pen doesn't want to work now. This is an x. And the C value is plus 50.13. 3, 5. All right, so we found a regression model. We're going to graph the regression equation and the data in the same graphing window. And I'm just going to put graph. I could turn my plots on in order to see those. And then I'm going to go to zoom, fit, zoom stat. I'm going to go to zoom stat. That'll give me a pretty good model. It'll automatically set the window for me so I don't have to do the thinking that I should do and that's required for that. All right. So now use technology to solve f of x equals 0. Explain the meaning of the solutions in terms of the problem. Now we know this is quadratic, so I can change my x values. Let's go to a negative 176. There's going to be another 0 over here. But would a negative number of days necessarily create more worms? The negative answer is not going to be valuable to us at all. What we really care about is this value. This is where f of x is equal to 0. So we want to calculate that intercept. I'm going to go to calculate. I lied to you. We're going to calculate that 0 left bound. So we want to get close to it. We'll scroll down. That cursor is to the left of the intercept, so the x values are less than. A right bound, I need to go a little past it. My x value is to the right. You can see it must be in between those. Any guess will do. And the 0 appears to be at 164.9. What does that mean? It means after 165 days, we will have 0 worms remaining. Worms. All right. Quadratic equations and models. That's it for this lecture. Thanks for listening.